Hi, everybody. Welcome to tonight's SJAA Imaging SIG meeting, November 2024. And tonight we have Scott Schneider, who's going to talk to us about observatory design. So take it away, Scott.
Hello, and thank you for the invitation to give this presentation. I really appreciate the opportunity to share some of my knowledge with the group. For those who don't know me, my name is Scott Schneider. I'm a licensed architect and I've been practicing architecture for a little over 20 years, which has given me an opportunity to work on projects at various scales throughout the US. In 2021, I started my own architectural design practice with the hope of integrating my lifelong passion of astronomy with architecture. And aside from my professional life, I'm a member of the SJAA as well as the Tri-Valley Stargazers, where I'm currently the newsletter editor. And I also enjoy camping with my family and doing astrophotography. So many people want an observatory, so their telescope is always ready to go with a click of a button. So tonight I'm going to talk about the design of observatories, in particular roll-off roof observatories. But some of the things that I talk about will be more broad and kind of can apply to dome structures as well. In general, whenever a new client comes to me for help, I begin with the seemingly simple question of what is the purpose of the building I'm going to design? And for observatories, stepping beyond the obvious purpose of providing a permanent place to house your telescope or scopes, I define the purpose as providing some protection from weather, some thermal control, fire protection, security, and in some cases for providing comfort, which could be living, entertainment, or office space, and where one can process his or her images and even possibly a gallery. But before getting into the design aspects of observatories, I'd like to briefly talk about building and property regulations. Normally, this is what can be considered as pre-design and should be addressed prior to commencing any design work. There are two fundamental types of regulations, those that regulate massing and zoning, and those that regulate life safety and construction standards. While in some cases, there may be some overlap between the two, zoning is typically permitted by planning departments, and life safety and construction standards are primarily permitted by building departments. And an example of where things may overlap is if we look at allowable building areas, planning department may have a rule that your building can only be a certain number of square feet. The building code also governs the overall square footage, but for other reasons. Usually one of the overlapping regulations will overrule the other. And this is why before you spend a lot of time designing, it's highly advisable to look into these regulatory constraints and to understand what's allowable. Sometimes you may not sometimes you may not need any permits to construct an observatory, but that doesn't mean you shouldn't follow the building codes. While there are many methodologies and materials to construct observatories, I will try to keep this talk focused primarily on the primary components of observatory buildings. With that in mind, much of this talk will be focused on pros and cons, as well as some rules of thumb for design as they relate to the purpose of building. So we will look at the site, the ground, the foundation, the floor, walls, roof, and openings. And I'm going to kind of go from the ground up. So while the site is an important piece of the puzzle, I want to focus my time more on the building. So I'm only going to briefly talk about the site. It is obvious that when looking for a site to build an observatory, we need to consider both environmental conditions as well as access. Grading can be a huge concern for observatories because usually the best places to locate them is on top of a hill. Usually this brings up many issues that aren't normally a concern at lower elevations, such as access to utilities, construction mobilization, to bring building materials to the site. Weather always is more extreme, and now more important than ever are wildfires, so fire department access is something to consider as well. Many remote sites are in areas which in California are wildland urban interface zones, or otherwise known as WUI. There's an entire chapter in the California Building Code dedicated to WUI zones, and it's chapter 7A. For more remote locations, a few things you can do to help prevent your observatory from being a building lost statistic is by creating a defensible space around it. The state of California Fire Marshal has some guidelines to maintain a defensible space around building structures, and they are split up as follows. So you get you have areas that are 100 feet to 30-foot zone, and you want to try and maintain 10 feet of clearance between trees. And in order to do that, you may have to remove some trees and regularly keep tall grasses trimmed. In the 30 to 5-foot zone from your building, you want to remove all tree branches that are hanging lower than 6 feet from the ground, remove tall grasses and dead plants and other flammable materials like logs or dead branches that might be laying around. And then maybe the most important zone is the 5 foot to 0 feet away from the building. And you want to make sure to remove dead plants, don't have any vegetation growing, like no flowers around, I guess, and use hardscape. And there's a few websites you can actually go to get more information about this, because it might be useful for your house too. Um, the Cal Fire has a website, and then there's another one that is kind of put out by the insurance industry, which is Wildfire Prepared. So in terms of the ground, soil composition and grading are major factors in determining what type of foundation system you should use. Soil is usually not made up of a single material, but rather is composed of many layers. And as you can see in this boring sample here is that there this particular location has a lot of silt and clay, and so you can kind of see that here. And then it has bedrock below, so luckily that the bedrock in this case was not too deep, and so that these particular foundations were able to actually bear on the bedrock to support the structure. Soil that is expansive is the least desirable, which are most of these very silty kinds of materials, because they absorb water and they can expand and contract. And of course, this can cause your building and more importantly, your telescope pier to move when the ground is expanding or contracting because of water. Sorry. Freezing and thawing can also impact the foundation and of course these silty types of soils are not great for that as either because if they can absorb water, they can freeze, and then when they thaw, they also move a lot. And it can actually cause your foundations to crack. While it's not always necessary to get a geotechnical report, depending on the quality of guiding that you want to achieve, sometimes it's a good idea to actually go out and pay the money to get a report. And then also, it really just depends on where you're going to be locating your observatory, where the site is.
Hey,
Because some
Scott, can I
places,
ask
yes.
a question?
Hmm.
So, if you're talking about your backyard, whatever you got, right? I mean, is this gonna,
Yeah. Well, I mean, most places it's what you have is what you have. And sometimes it's more known than other places. Like if you're doing something more remote, the soil may not be as well known in those places as it would be in your backyard.
okay.
And there's also if you go on to I guess the USGS, they also have maps that kind of show where expansive soil may exist in a larger scale in around cities. So, and then in terms of load bearing, bedrock is obviously superior, whereas silty and then expansive soils are able to bear a lot less. And like in this case, you can see it's kind of you get 1,500 PSI, or I guess pounds per square foot, sorry. And then for bedrock, you get 12,000. So that's 8 times more bearing capacity for bedrock. And the same is true for lateral expansion, which would be like earthquakes. And you get in for earthquakes, it's even worse. It's like more like 12 times difference between bedrock and more silty types of soils like clay or actual silt.
So, Scott, what would the downside be? Let's say you put you want to build a backyard observatory and you have, the silty stuff, but that's what you got, so you do it. So what you're saying is, I suppose that the thing will move over time. But
Well,
is
I
that a
mean,
big
there's
deal?
ways of getting around that. I think
But I'm saying it's not a
foundations have
big
to be
deal if it,
much larger.
but say it did move. Is it just, well, okay, it moved, I'll polar align it, every month and I'm
Yeah,
good?
that's pretty much so. Yeah.
And then
Yeah.
it's not, I mean, but I would argue that's not a problem. Great. It's not that big a deal. Unless it's in a remote location, but if it's in your backyard,
Yeah, if it's in your backyard, it's not as big of a deal as it's somewhere far away where you have to travel to get
right.
there to change something.
Okay, so you're talking about more concerns for a remote location that you don't want to necessarily um, go to.
Yeah, but it's also, I mean, it can affect costs too, building an observatory because you're going to be doing a lot more concrete. And then you're probably also digging, doing a lot more digging and you're going to be backfilling more soil too because you're removing soil to do form work. So does that answer your question?
Sorry, yeah, I'm
Yeah.
good. Thank you.
Okay. Yeah. Um, so drainage is another important factor and for foundations and for soil. It's really important and it's very helpful actually keep the water away from your foundation. So, and obviously like silty soils, it's ever more important. You want to keep these, you want to try and move any bit of water away that you can. Um, like in your house, you probably have drainage tile and some places where you may have to have like a sump pump to pump it out and get it away from the foundation. Um, some sites where soil is really poor, you can actually you can remove that soil and truck in better structural type of soil. Um, it has to be compacted and that can take time. And it's obviously, comes with a kind of a hefty price tag. Sandy soil can be okay if you're on a flat site, you can do mat slab foundations, which I'll show in a few slides down the row here, but um, they are they're a thicker slab and they're actually like a two-way support. So you'll have rebars going in two directions in them. And you can also do um like just a slab with a thicker edge around it to help support the walls. Um and then when we start getting into the topsoil and finishes, it's a good idea if you have um mainly like posts or something and you did piers for your foundation, you have the underside of your building is exposed to put gravel underneath, and usually you want to try and put a landscape fabric underneath there, and you would want to underneath the building you'd want to use more of a woven type of fabric so that you slope that fabric and then you place the gravel over it, and then the water would then slope away from the building. And when you get out to the edges of the gravel, which you want to kind of place maybe like, 3 to 5 feet away. And in fact, like if you're in one of these WUI zones, you really want to get it more like 5 feet away. And then you can use an unwoven fabric to let the water kind of permeate through it. Um, you can also use pavers instead of gravel if you like to, for more aesthetic reasons. Um, but I think it's a little bit better to use gravel, um, because it's just more permeable and it helps, I think, if you're using these kind of barriers underneath it, it helps get water away from the building, from your foundation. And then in terms of foundations, there essentially are two types of foundations that are done. There are shallow foundations and then there are deep foundations. And deep foundations are really something that we wouldn't really use them on observatories, but I just mentioned them to, like maybe like our larger observatories are using them if, getting down to bedrock. And They, but one of the differences in them is they use piles and caissons. They kind of look the same. They're both like this long pier that kind of goes into the ground, but one of them is driven in place, and then the other is poured. Um, but the foundations that we typically use would be the shallow kind, and we have wall and spread footings. Those are you can use them on flat sites. Can use them on slightly sloping hills. I mean, when the hills kind of get too steep, you would probably want to switch to piers because you'll just end up using a lot more concrete and you don't need to really spend money in that place. And then piers work on great on sloping sites. There's combined footings, which might be a combination of a wall and a column that are joined by a footing, where like if you're supporting a larger floor, you might have a column in the middle and the footings are attached to one another to minimize movement. And then there's thickened edge slabs and mat foundations. And the slabs are great for when you're in places that are, where you don't have like freezing and thawing happening because you don't have to, you're not going down to the freeze to the freeze line in the soil. Mat foundations can be really great, as I mentioned before, when you have sand. Um, in fact, like they've used these it was actually invented in Chicago for one of the auditorium theater, if anybody's ever been there. Um, they were actually on marshland there, and they built a giant mat slab to distribute the weight of the building. But they can be great for observatories because you can you don't necessarily need to use piers in the ground. You can mount your pier directly to the mat slab because they're, typically designed by a structural engineer. Anybody have any questions actually about foundations? About more just the types of them? Otherwise, materials, we have poured in place of concrete and then CMUs, and really CMUs which are concrete masonry units. You'd really just be using those for maybe a partial height wall or something like that, but the rest of the foundation you'd want to do in poured concrete. Um, Typical load capacity for concrete is 3,000 psi to 5,000 psi. Can it can be much higher than that. Um, like bag concrete that you get from the Home Depot is right around 4,000 psi, and that's usually, good enough for what we would be using it for. Because you're not really, you're not putting a lot of load on the concrete. If you have to get a permit, usually rebar and bolting, any kind of like anchor bolts or anything like that is requires special inspections before they'll sign off on the permit. And then
So Scott, are you going to
yeah,
be talking about like what kind of projects need a permit and what don't? And
well, I mean, it really depends on the jurisdiction a lot of times, and it's sort of hard to generalize about that in a way. Um,
so if I put a pier in the ground and no
Yeah,
build,
like you put a pier in the ground, there's really things that affect like life safety, and if they get over um like a certain size, which I don't really know what it is offhand, but um
but I mean something that just holds a telescope, a pier for a
yeah,
telescope.
like something that just holds a telescope, you don't need a permit for that.
Right. So then now
Um
if I want to put a shack around that, if I go to Home Depot and buy a shack and put around that and cut off the roof, that's not a permit, right? It's when,
yeah, not necessarily a building permit, but you may have to get something from planning,
oh, I see.
if you're doing it in your backyard. Because I'm sure there's rules about, accessory structures and
Okay.
yeah, yeah.
And
Yeah.
I suppose, bringing electricity and internet to that thing.
Yeah, anytime, like if you do, like if you want to bring, like electricity into it, you're gonna have to get a permit for the electricity. And then your building is gonna have to be up to code. Because you can't really run, they're not gonna let you run wires in a building, that wasn't necessarily permitted or at least up to building code standards,
All right.
which are pretty low, and that's why the building code is kind of it's really a great resource actually for construction, just standards of building. Um, so people kind of, I think you don't want to pay the money to get a building permit, but I think, even if you don't get one, it's really good to at least follow the standards for building construction because you never know, like you might want to, I want to run power or I want to run water out there or something.
Scott, what about using a solar panel and a battery? Does that change the permit requirements?
Well, solar, I mean, again, I think that kind of depends on the jurisdiction. Um, and like solar sometimes requires permits, like if you're gonna put it on your roof, like it, um, there's a load there coming down on your roof, so they'll require a permit for that, in term for building. If planning may require something, it just really depends on the jurisdiction of where are you doing, where are you installing it. Is there any other questions? Or though?
Not a question, Scott, but hey, I'm working on Imran and I are working on a remote observatory build, and
Hmm.
what we're finding out is that it seems to be really county dependent. So if you're working in a particular county, it's good to go to their website and see what kinds of buildings require a permit. So we're in Monterey County, and
Hmm.
got that any building, regardless of how big it is, if it's got electrical, then we need to get a permit.
Yeah. Yeah, that, I mean, makes sense. Um, yeah, I mean, some jurisdictions are, um, the county kind of does the permitting, and whereas if you're like in a city, a lot of times the city is doing the permitting and, um, so it makes sense that when you're in a more rural area where you are a tree, that you would be going to the county. But yeah, it's always, as I kind of said in the beginning, it's always really good to check these things out even before you start any kind of design is go to the county, go to your planning department and, see what their requirements are. Getting back to concrete, the concrete, I think I left off at the bearing capacity of concrete. So kind of moving on to the cure time, concrete, after you pour it, normally it is almost to its full bearing capacity in 3 to 7 days, but it fully cures in 28 days. So usually in 3 to 7 days, you can start like putting, framing on top of your concrete. One of the things about concrete is that it has a high thermal mass, which is, kind of goes counterintuitive or counter to what you want to have in your observatory because concrete can absorb heat during the day, and then at night it can sort of let the heat off and it goes slowly. And actually a lot of times concrete is used as a thermal mass for passive heating in houses or other types of buildings. So one way to kind of deal with that, well, it's not going to totally fix it, is you try to cover it up. Don't expose it to the sun, put insulation around it. But ideally, you don't try to build your whole entire wall out of concrete. You kind of limit it to the ground and you try to cover it up. And then I wanted to go through a few just basic rules of thumb for different foundations that you might use to build an observatory. The first one would be like a concrete wall on a spread footing. So you really want to start out, just because of rebar coverage. A lot of times walls are going to be at least a minimum of 8 inches thick below grade. Footings, the kind of thickness of the footing would be the same thickness as your wall. And then the width of the footing is usually 2 times the thickness of your wall. That it's supporting. And then if you're in an area where you have the ground freezes, you want to be about 12 inches below the frost line with your footing, so that when the ground is freezing or thawing, it's not affecting your foundation moving. And then in terms of rebars, when you're above grade, you have to maintain 2 inches of coverage. And so that means like the rebar needs to be at least 2 inches from the face of the concrete. And then when you're below grade, that is 3 inches of coverage. And that includes if you have stirrups or ties or something like that, the ties have to be also fully covered by that 2 inches or 3 inches. So your rebars may actually be in further, is the point of that. And for piers, same rules for coverage. You'd have 2 inches above ground and 3 inches below ground. And then when you get to the bottom of the pier, that would also be, you try to keep your steel rebars up about 3 inches above the bottom of the pier. Round piers, they should really be designed to be 12 or 14 or 16 inches in diameter, because that's the size of most auger bits that you can rent, or if you own one. In that way too, if you can literally just use the auger and drill down to the depth that you need for your pier, and you wouldn't necessarily need to use a sonnet tube there, and you just pour your concrete against the soil. As long as the soil is undisturbed, like you haven't dug a larger hole around your pier or concrete. And there's a guy named Jim McCatherine. He's a fellow architect who he wrote a really great book actually, which goes into a lot more detail and into the design of foundations and specific to telescopes. And the book is called Telescope Piers, and I have a link at the end of the slideshow here that you can use to get to his website if you want to take a look at the book. And I think the book was like $12 or $14 or something like that. And it's just a PDF download. And then for slabs, it's actually kind of a good idea to do like a little stem wall to turn a wall up from the side, and that helps actually get any kind of wood framing that you might have above the ground, and keeps it and you actually have to do that anyway, because like as you'll see in some later slides, like any wood that's above the grade needs to be at least 12 inches above the grade. I think it's 12, but um so it's actually good to use concrete down there. And that also helps if you in WUI zones where fire could be a problem with embers. Um, Stem walls should probably be about 6 inches thick, and I believe that's even the building code has a minimum thickness, and I believe it's 6 inches. Um, yeah, and here's where eight 8 inches. I think 6 inches is actually the minimum height above grade, and 8 inches is better. And if you're doing wood again, you have to have it needs to be even higher. So, and then the same rule applies for rebars in terms of coverage. So with the 2 inches and the 3 inches. Um, Mat slabs are typically designed by a structural engineer, as they they are a complete structural slab, and any weight of the building is really being supported by that slab, versus like maybe a slab on grade, which the part of the building is really only being supported in the edge condition. Anyone have any questions? So floors, and you can actually use concrete as your floor, and so it's a good way to kind of save money if you're on a flat site. Um, and if you're, in an area where you don't have the freezing and thawing, um, they're a really they're a really good solution. Um, and just, thin slabs like the 4 to 6 inch ones, you like they're kind of a do-it-yourself um type of construction. Whereas like a mat slab, you're really gonna need a contractor for that, because you're gonna be pouring a lot of concrete. Because they kind of start at around 12 inches deep and can go to like 18, just depending on what type of loads there may be on the slab. And I think for, telescopes, you're gonna want something a little bit thicker, just heavier, more rebar, just for if you're drilling in multiple piers. And people, there may be people walking on it at a certain time, and you don't want to disrupt the observing. It's always good to place a vapor barrier underneath the slab so that you don't get moisture transmitting from the ground through the slab, because concrete is actually very porous. You can place insulation below the slab, but it would be above the vapor barrier. Usually if you do that, you'd want to put down like a layer of sand just to kind of protect the vapor barrier from puncturing, from gravel or something like that underneath it. The concrete can be the finished floor. You can seal it or paint it. Or you can install 2x4 sleepers just turned on their side, and you can put insulation in between that to kind of keep the temperature, keep um any kind of solar gain or something happening from the exposure of the concrete from radiating through at night. And then on top of the sleepers, you can install 5/8 or 3/4 inch tongue and groove plywood for subfloor. And then if you wanted to have some kind of like finished floor on top of that, you could install it over the top of that.
And Scott, I have a question for you.
Mm-hmm.
I've heard people talk about isolating their telescope pier from the
Oh yeah.
floor,
Yeah.
as opposed to having it part of the floor.
Yeah, so I think in all situations except for maybe like a mat slab, you'd want to separate and do separate pours. And you normally, like a 1/2 inch is probably good all the way around the pier. And if you're like here, if you're in a like with the wood frame floor or something floating above that, and you have the concrete, maybe the concrete sticking up and through it, you can put like steel wool or something like that in the in that joint in between to keep bugs and rodents out of there. Oh, you're not, I don't, you're muted.
Sorry. So
Yeah.
so say you had, I don't know, a pier, a concrete
Mm-hmm.
going to the ground, and then maybe you had just some kind of thing around the building. I forget what you call that, but not a slab floor, but a foundation around with the structure. How much concrete would you pour for your telescope pier?
Well, nor like really, you kind of go back. It's a few things. So one is like, what, how big is the mount you're putting on it? Like what does that require in terms of bolting and that sort of thing? And actually, like, I would, I wouldn't run concrete all the way up. I would actually do like put a steel pier on top of the concrete.
Okay.
Um, and again, like the size of the concrete's just really going to depend on um how big is the mount, how much, what are
I've
like,
heard people say things, and it just sounded crazy to me, but I wanted to bounce it off you. It's like, a cubic yard of concrete under the ground for a pier. And is that
yeah, I mean, it's probably that sounds ridiculous.
okay? So you agree?
But
Okay.
it depends on the soil too. It really depends on the soil. Like if you have really good soil or you're on like bedrock or something, smaller, you can get away with smaller, but if you're on something that's more silty, that you're gonna need a larger foundation because that the soil can only bear so much weight.
Uh-huh.
So you have to spread that around. And and it also depends on what type of your guiding you want to get, if like movement. And
Uh-huh.
so it's sort of it's kind of a hard thing to generalize.
All right, but that
And
does
actually,
sound like a lot.
this book that I mentioned, he he actually it's actually a really good book. He goes into he really goes into depth of like designing footings and stuff, like like piers for your telescope. And he actually has a whole like a chart of different sizes and what to expect from them. And so I highly, if you're really considering this, and especially as kind of a do-it-yourselfer, like get that book. It's like $12 or $14.
Okay.
Read
Thanks.
it. Yeah.
Hey Scott, I have a question.
Yeah. Go ahead.
Being as we're waiting for the big one to hit California,
Yeah.
um, is half an inch, would that be sufficient for the big one?
You mean like a gap between?
Yeah, the clearance between the telescope and the floor.
Well, like, this is another thing that depends on the ground, like the soil, and it has to do with deflection. So the code, if you're going out and, well, even if you're not getting a permit, the building code really specifies the minimum sort of deflection, or I should say maximum deflection value. So and it's really just driven by the soil, that like what it can withstand. Um, I mean, and it also depends on how tall, like what the arm is, what's the cantilever. So when you're close to the ground, it it's not really going to move as much as it would when you're up higher. Like think of a kind of like if you're balancing a baseball bat in your hand, like the top of the bat moves way more than the bottom of the bat when you're trying to balance it.
That makes sense. Thanks.
Yeah, yeah. Um, so wood flooring, uh, it's a great choice for locations where you're sloping, where you're doing like a conventional wood frame floor where um 2 by joists. I think 2 by 10s is kind of a good starting point. And it really, the sizing of them really just depends on your span. And actually the building code and even um like lumber suppliers, or they actually have charts which kind of show like maximum spans for lumber, so it's always good to check that out. But as a starting point, I think 2 by 10s is kind of a good place. Um, on when you're connecting the floor framing to a concrete wall foundation, you need to put in a sill plate, and that sill plate, it's a really good idea to use pressure treated wood, and especially like in earthquake areas, it's good to use 3 by lumber, so it'd be like a 2.5 inch thick piece of wood rather than a 2 by piece of wood. Um, and then if you're doing piers, like what's shown in the picture here, there's a company that makes they make column bases, they make all sorts of wood framing connectors, and they're, it's Simpson Strong Tie, and you can actually buy them at Home Depot, and they make joist hangers, they make screws, like just about it, all sorts of structural connectors for framing.
So Scott,
Yeah.
just a quick question. That is mainly just to avoid rot, right? It's
Oh
not,
yeah, totally. Yeah.
that's the only purpose for it, right?
Yeah.
Okay.
Yeah. So it's always, it basically lifts, well, it does a couple things. It not only deals with rot, but it also ties like in this case, it ties the post to the foundation,
Mm.
which is the important thing. So your load is going directly down into the ground, and kind of dissipating.
Because I was just thinking, if I'm thinking about, making a foundation and putting a steel pier on top of it, I don't need this thing, right?
Yeah, right. Yeah, you don't need that.
You need it.
Like if
This is
you're
basically
putting like a steel pier on
like Ioptron one that we were talking
yeah,
about.
yeah, exactly. If you're putting a steel pier on top of like a concrete pier,
Mhm.
you would, you'll have your bolts coming out of the concrete
Concrete, yeah.
and you would run them a little bit longer
Mhm.
so that you can level the pier, basically,
Right,
the
right,
steel pier.
right. Okay, got it. Okay, that's fine. Thank you.
Mhm.
Scott, one other comment
Yeah.
with piers like that. One thing people sometimes forget is when they do a cut end on pressure treated, the core of the wood is not pressure treated. I would recommend, copper naphthalate or something on that cut end to prevent rot from going up the center.
Oh yeah, that's a great point. Thank you. Yeah. Yeah, so yeah, so basically any wood framing should be a minimum. I thought before it was 12 inches, but it needs to be a minimum of 8 inches above the finish grade. And any wood, you can actually have wood below that in the building code, but I wouldn't recommend doing that. But if you do, again, use pressure treated wood to in those areas. And then, we kind of talked about this, maintain clearance around the telescope pier. And you would do this with concrete or your framing. And then the gap can be filled with steel wall to keep any kind of bugs from going in there, or just something that is compressible that doesn't affect your pier. And then in colder environments, you can insulate the floor. You can put like marine grade plywood on the bottom of the framing. And then maybe like in WUI, you may want to use more of a, add some sheetrock to that so that you have some fire protection. And then again, when you put your sheathing on the floor, you can do 5/8 or 3/4 TNG. I think that's all. And then anybody have any other questions about floors before I move on to walls? All right. So for walls, you actually for floor framing too, you can frame or framing in general, you can frame with wood or you can frame with metal. Um, most of the time if you're doing this yourself, you're probably framing in wood. So for wood walls, there's conventional 2x wood studs, and then you can also do post and beam construction where you're maybe just using 4x material or 6x material. I think, you know, stud walls are probably a little easier to work with. They're they they cost less, and they're readily available, but 4x and 6x are pretty much available in most Home Depots as well. If you have to get a building permit, framing actually requires an observation. post and beam, you know, you can you're using larger members, but less of them. They're a little bit more expensive than the conventional 2x members. And again, they require observation if you're getting a permit. And if you're doing metal framing, it's, you know, it's pretty similar to wood framing in terms of, um, you know, there's lightweight and then you have more of a post and beam. You can get metal studs that are in same sizes as 2x members. It's a little more expensive than wood, but metal is really great in a lot of ways because it's more consistent. You don't have to worry about warping and shrinking and splitting going on. It has, it's, you know, it has, it's actually, I should have said it has very high thermal conductivity, which is great for, you know, in our case, because you know, as quickly as you gain heat, you get rid of it. It's resistant to mold and pests. And then you have, you know, larger steel members, more like, you know, you might think of these as like steel tubes, and you could do your whole structure out of steel tubes. I mean, this is something that would probably be designed with, you know, with the structural engineer in mind. Although, you know, you can kind of do a combo of the two, as you know, of wood and steel as well. So you could use um the steel tubes for your gantry, and then because you can get pretty long members for that actually. But you know, steel is not usually a do-it-yourself kind of solution. The other really good thing about using metal framing is that it's a non-combustible material. So if you are, you know, like tree, that you're in an area that is more remote, it's, you know, it's a really good material to use because of fire, you know, the possibility of fire. And then if you have to get a permit, you know, welding and bolting requires special inspections. Any questions? And then, you know, you can do poured in place concrete or CMU walls. Like for example, the observatory that my other astronomy club is building, TVS, they are using CMUs, which I don't totally recommend, but because of the you know, solar gain that concrete and CMUs tend to carry with them, they, you know, it's just not a great material to use around telescopes. There there's actually, I believe, when I heard this story about when they were building the observatory for the for University of Boulder, they ended up they had clad, I think the building was made out of CMUs or concrete or something like that, and they ended up having all these like heat problems actually, and they had to go in and put like air conditioning in, and you know, kind of go in and retrofit with a mechanical system to deal with the heat problem that they were having. So one thing you can do though is build, you know, if you're concerned about fire and this is, you know, maybe a really good thing to do, if you're in an area where there's fire or potential for wildfire, is to build a lower, like a stem wall out of concrete. And then you put your framing on top of that so that any kind of embers that might be blowing through the wind, they hit the concrete and they don't burn. They don't start your structure on fire. At least there's a lot less potential for that. And then moving on, no one has any questions about walls. I'm gonna move on to roofs. So I think for observatories, there are essentially three types of roofs that you may use for a roll-off. A flat roof, a shed roof, or a gable roof. And I think starting with a flat roof, and they're great for shorter spans, smaller observatories. They're lighter weight. You have less framing going on in them. You can insulate them in between the joist or rafters. You would just do like a 1/4 inch per foot slope for drainage, and you can just run it one, if it's a pretty short span, you'd just be running it in one direction and let the water either go into like a metal gutter or just let it actually sheet off the side of the roof. You can actually use the waterproofing membrane as the roof finish, and depending on the type of waterproofing membrane, because there's many different ones that you can actually get colored membranes so you would try and get something that's a lighter color so that you're reflecting any kind of solar heat that you might get from the sun. They're maybe not the best choice for areas that are prone for wildfires, because you can get, embers could actually sit on them and potentially ignite it. In those areas, no matter what, you'd have to use a Class A type of roof, which is really it's a material thing. So certain materials or all of them, I guess, are put into different classes, and when you look for specs on these materials, it'll say whether or not it's been rated to Class A. Moving on to shed roofs. These are also great for shorter spans. You can do longer spans too. They can be built with trusses. They're just sloping in one direction, so they would potentially be, depending on which way you are sloping it, they could be taller than like a gable roof, which is pitching in two directions. The slope, usually they need to be at least 3 and 12, and it really depends on the finish material that you're going to use, because certain roof finish materials are, they're only warranted for slopes, for certain slopes. And a lot of times it kind of starts with 3 and 12 on, like for shingles or for metal roofs.
I had one
Yes.
question. Do you have any recommendations on venting the roof? Since that could be a large solar intake.
Yeah. Actually, I go down next couple slides. I have
Oh,
something
sorry,
about it,
sorry.
but yes, like venting is a great idea. I highly recommend it. And we'll get to that in just a minute.
Scott, just another question.
Yeah.
How
Yeah.
how long of a span can you reasonably do with a sloped roof?
Well, again, it's sort of it really depends on the design. If you're doing trusses, they can span longer.
Mm.
And it really, really depends on the design of the truss. And even like the size, like when you build a truss, like you can have members that are like 2x6s, and they can, like a 2x6 can kind of span longer than a 2x4. And so even just the members themselves can determine how long the span is within the truss. And so the trusses can get fairly large. So and I think a lot, like SRO, like they have, if you've looked at pictures of SRO or if you've been there, that's like that's all like a truss.
That's good to
That
know. Thanks.
Yeah, yeah. Yeah. So, and then gabled roofs, they're very similar to shed roofs. They're just pitching in two directions. Um, they're probably a little bit better in places where it snows, because you're pitching in two directions. So you're not, hopefully, snow isn't sitting on there. I mean, and if you're in a place where it snows, you need to design, the roof needs to support the snow load. And that's something that you would determine more locally with the whatever jurisdiction you are in. Because some places they get more annual snowfall than others. So um but again, like Tree's question, trusses can be used in these roofs, so they're they're good options. Um Overhangs, I would avoid large overhangs, but overhangs are actually a great place to put a vent for a roof, and then you would have something at the top, so you can have ridge vents at the very top of the roof, and then you have a soffit vent in at the bottom of the roof, and that helps airflow. Um, there's also, when you're in a place like a WUI zone, there are actually vents that are rated for WUI, and I'm gonna share a link later on in the slides that where all the products that are actually approved for WUI are there's a huge list of all kinds of finish products, from wall finishes to vents to roof finishes, that are all approved by the state fire marshal. Um, and again, like the other roofs, you can add insulation to your roof to help mitigate some of that, and help mitigate and minimize some of the solar heat gain that comes from the roof. And again, you want to use like light colors for your finished material to help reflect some of the sunlight. And then the gantry, the beam obviously needs to be large enough to support the roof as it is moved onto the gantry. Um, you can use load tables to kind of determine the size for a gantry. And again, those are found in like the building code, or um, the lumber companies that actually provide lumber, like Weyerhaeuser would be one of them. And then, like 4x material is kind of a good place to start for your gantry. It just really it also depends on, just the design overall of your track system. And then if you're using wood, it's actually a really good idea to add flashing at the top of the wood to, in case there's any kind of water that would happen to be sitting on top of the wood, and after it rains or something like that, to prevent rot. And it's a little bit better than painting because you don't have to keep going back every few years to repaint it. You can also use like, 3.5-inch square steel tube for your gantry. But you want to be sure to keep that painted to keep from rusting. And you can add heat tape underneath. It depends on your track system, but you can add heat tape to that, to prevent ice from forming. And then, in terms of finished materials, again, use like reflective reflective types of colors. So like white is obviously, or light colored materials are good to use for your roofs, even for the rest of your building, actually. And then again, like most roof finish materials require specific minimum slopes in order to maintain their warranty, as well as just to have them work effectively. And then for automation, for motorizing your roof, there's a couple, I think, really great solutions out there. And one of them is Dark Dragon Astro, and then the other is Interactive. And they sort of provide kind of a full system for your roll-off roof. So full automation, I should say. And then, for additional security, you can provide electronic bolt locks, especially if you're somewhere remote, and you can, kind of keep your roof locked, just using like a IP-based controller with the bolt lock. And it's kind of a specialized thing, but you can buy these things on Amazon too, so. And moving on to just some general thoughts on openings like doors and windows. You can build your own door, or you can get a standard size pre-hung door, which is what I would do rather than building your own, because you can get a solid core door, which is much, you want to use a solid core door on the exterior. So avoid, buying like a hollow core door, which is more of an interior application. For smaller observatories, or even observatories where the door may be close to the telescope piers, outswing your door. And I would also, get like a 3-foot wide door so that it's easier to bring things, bring equipment in and out of the observatory. You can even get double doors if if you have larger equipment that you're trying to bring through. And in terms of door hardware, if you have an outswing door and you want something a little more secure for hinges, you can consider replacing butt hinges with concealed hinges. This can help stop someone from popping out the pins and potentially removing the door. And then you can also, for remote observatories, you can even consider getting like a mortise lock set. These they can be more expensive, but you can get them electronically controlled, and they can be controlled via like an IP-based controller, like over the internet. And then for windows, if you want to have a window in your observatory, I would, if you're going remote, I wouldn't skimp on the glazing. I would get insulating glazing, and as it can help with heat gain inside the observatory. I would get aluminum or clad, like wood aluminum clad windows, as opposed to vinyl, especially if you are in a WUI zone, because vinyl can start on fire more quickly than aluminum can. If you're building a backyard observatory and you want a window, they're great because you can open the window in the summer and, as ventilation. And then I have a couple slides about just protecting your investment, especially if you're in a WUI zone. And foundations, I mentioned this before, you can use a wall or like a stem wall and extend the concrete up above the grade, and that'll stop embers from getting below your floor framing and igniting your framing. Building, and if you are on a hill and where, like a wall may not be feasible, you can, either you can build like a fire rated wall down below the framing, or, below the floor framing, or you can use something like Durarock around and place that all around the perimeter of the posts. And then for floors and walls, use rated assemblies. And Chapter 7 of the California Building Code, and there's also UL Underwriter Laboratory listed assemblies that you can. There's thousands of them actually, like in the UL book, but Chapter 7 of the CBC also has a bunch of different fire rated assemblies, from floors to walls to roofs. Vents, you can use WUI certified vents, and basically what those are is they have, I think it's no larger than 1/8 inch openings in them, so that they vent, but they prevent like embers from being able to get into the vent and starting a fire. And they make them for soffits, they make them for walls, and for roofs as well. And then, for all exterior finishes, you can use materials that are approved by the state fire marshal, and here is a link to the website where you can actually download that it's a giant PDF. For doors, get a fire rated door assembly, and it's actually the whole assembly that is rated, not just the door slab. And your typical, like when you're in a house, your typical door is actually like a 20-minute door that you have, and you can actually get better, or you can get like 60-minute doors or 90-minute doors as well. Windows, if you do decide to put windows in the observatory, use tempered glass, at least, if not on both panes, definitely on the inside pane of the glass. Because when the first one falls out, the second one is still there protecting it. And use like aluminum windows or clad, and definitely stay away from vinyl. And then for the gantry, you can use steel in that case. And then in closing, I wanted to provide some more links to a few of the building codes that we talked about, and then defensible space, and then this is that book I was telling you about for designing piers, and then my own website. And that sums it up.
All righty. Thank you very much, Scott. So,
Yeah.
well, are there more questions for Scott?
Yeah, this is Larry.
Mm-hmm.
Scott, would it be possible to get a copy of your presentation?
Yeah, sure. I can make this into a PDF and share it.
Yeah,
That's totally fine. Yeah,
But just
I'd
put it
love
on,
to
if you
actually.
want, put it on the mailing, reply all on the email.
Yeah. Yeah, like I can share a link to it maybe on my website, and then
Or that, sure.
anybody can go download it then.
yeah.
But
Yeah.
I can send out an email on the list, and then to a link in that.
Yeah, that would be very helpful.
Yeah.
No, it was a very, very comprehensive and very insightful presentation, Scott. I really appreciate it.
Yeah, thank you. Yeah, and,
Scott?
like if anybody after the presentation has questions, you can always send me an email.
Okay.
Scott, there are two or three companies that specialize in building home observatories. As far as you know, would they know how to be code compliance and that kind of thing?
Yeah, I mean, I think it some like I know there's one in particular, they sell like floor plans and stuff.
Yeah, shed
Um,
something or another.
yeah, it's like Shed something, I forget.
Sky Shed, I think.
What is it? Sky Shed? Yeah, yeah.
Yeah.
Yeah. I mean,
And
they sell
Blue
plans. I don't really know. I'm sure some of it is probably code compliant, but um, like California has some, actually they have, items that are added to the kind of general code. And so maybe not all things would be code compliant. I know there's a couple, I think there's two companies that are located in Southern California too, that they're contractors. They build telescope observatories, and they sometimes they do them at like universities even. But they they're probably going to be a little bit better, I would say.
Great presentation, Scott. I have a question about uh, fires. So I've seen some products where you can put this kind of metal um, fire rated material on the outside of a building in a high fire risk zone. What are your thoughts about those kinds of products?
Well, I'd probably have to see it. Um, just to it's kind of hard to answer without seeing it, but I mean, I would say in general though, like anything that anything that kind of claims to be a product like that, it should be listed, like UL listed or or approved by like the state fire marshal. So I would, when you're looking at stuff like that, I would definitely make sure, like, go to that website and download the list and for the state fire marshal and see if these products are on there. Um, but even, UL listed products are also, I think the state fire marshal, allows for the UL listed products. So, but they have to be, there's certain like testing standards um, that they have to use. So it would, a lot of it really depends on, that whatever testing standard that they used. So hopefully that kind of answers your question.
Thanks. It sounds like the safest way to go is just to have a metal building.
Well, yeah, I mean, metal is great, but metal can melt too. So, um, you have to, you know, there's steel studs. There's fire rated assemblies for steel studs because they get hot and they they become more elastic. And so they also need to be protected. But metal is great because it's non-combustible to begin with, so that's a that's a better thing to use.
Yeah, sometimes it's not the fire, but the heat. And so probably a critical aspect would be the surrounding area and to, as much as possible, fireproof your perimeter.
Yeah,
There have
yeah,
been
that's
some,
exactly, yeah,
yeah,
that's exactly why I brought up like the defensible space. Like, um, yeah, that's like fire, a lot of times, like I actually watched this presentation a few months ago about defensible space actually, and they showed all of these videos of like how ember, in fact they were, like the fire that happened in Maui, um that like they were showing how like it was just wind was blowing all these embers across, just it was just flying everywhere. And they were, maybe like 1 inch diameter embers or something like that. And these things would land on the ground and they would sit and glow, and that, and especially it, like kind of maintaining the space around the observatory is like super, super important, if you don't want to become a statistic.
And then on the topic of roofs, how if you have solar on top of the roof, do you feel like that would be like, and let's say you have a south facing sloped roof, do you feel like
Mhm.
that would be a pretty effective way to help mitigate solar heat gain into the building?
Well, I don't know. I mean, I guess, it could be. Have to, I mean, again, I think that's something you have to really be able to see more of, like, what is the system and,
Mhm.
what's underneath it. And
Yeah, let's say they're sitting on top of footings on top of the roof, and so you have an uh, air gap between the
yeah,
roof and the solar panel itself.
yeah,
Say, close to 100% coverage of.
yeah. I mean, the thing, it's like the solar panels are absorbing a lot of the heat, and then it's being, you know, transformed into electricity, right? And so there's like a certain efficiency to it. And what it's kind of like what happens to the part that's not efficient, is that leaving as heat? And so, I mean, yeah, I think the thing would be to have an air gap there. It's just how big that air gap should be is maybe the question.
Well, I mean, obviously that adds weight to the roof.
Yeah.
You're
Well,
gonna,
there's a whole nother like electrical problem too, of like moving wires and
right. So it wouldn't, to me, it doesn't sound intuitive that you'd want to do that, but
yeah. Yeah, I mean I probably wouldn't, but
Or like solar shingles.
yeah, I mean there's the wasn't Elon doing something with that, trying to make solar shingles.
Yeah, yeah, no, they're available for sale.
Yeah.
There's a few other like solar film, not film, but yeah, like flexible solar. Like you see them on like RVs, where it's kind of like a membrane, basically,
Mm,
like a solar
yeah.
membrane.
but like you were saying, Scott, I mean, solar panels are black for a reason, right? Because they
Yeah,
want
yeah,
to absorb
yeah.
as much of the light as possible, but you probably reflect off more heat than the efficiency of the solar panel if you had a white roof.
Yeah. Yeah. I mean, what is this,
Roof,
efficiency of a solar panel? Is it like
Yeah,
25%.
20? Yeah.
yeah,
And so the other 75% is like what?
yeah,
Uh,
and they're dark, and it's absorbing
yeah.
all the
I mean,
other.
a membrane probably sounds not like that. I probably wouldn't do, because like, well, at least membrane sounds very thin, you know, even though it's like lightweight, it's, if if the efficiency is only like 25%, there's a lot of heat there.
I think TriPoint's point is though that the solar panel shades the roof, so the roof's not getting any direct sunshine. And if there's a sufficient gap, there's going to be very little heat radiating from the solar panel into the roof.
Yeah.
And if the roof is white colored, then you've not only got a white colored roof, but it's in the shade. So that's got to be a win.
Yeah.
But I
They-
understand your point on the wires and the roof moving. So I guess that's one problem needs to be solved.
Yeah, and the weight is a real issue too. But they do have these bifacial solar panels now that have even more efficiency, where like if you have a white roof, um, then any light, even ambient light reflecting off the roof, hits the backside of the solar panels, and so you get even more efficiency. But yeah, no, I see the point about like needing to make sure you have like really good insulation, uh,
Mhm.
and even ways to reflect the heat back. Like some people will put like I don't know what it's made of, but like it looks like aluminum. You stick it onto the back of the roof, then you put the on the bottom side of the roof, then you put the insulation, and that helps supposedly to reflect heat back out.
Yeah. Well, Tree, why don't I mean send it to me, You have my email.
Yeah,
I
I have
mean,
your Facebook Messenger too.
yeah. Yeah.
If you have the space available to try to on the ground, you could set the solar on a separate stand outside. And so you wouldn't have to deal with the moving issues of the roof.
Yeah, that's one option. The space that we're looking at, it's kind of on a hilltop.
Yeah.
It's like 30 by 70 feet. So yeah, we do have other areas where we could put the solar panels and then run the wiring to
You
the
may have to
battery
buy
banks.
more property and cut down more trees.
Yeah, it's a lot of ridge lines, a lot of not a lot of flat space.
It sounds like fun though.
The rugged ridge.
Yeah, I mean, I think, you know, when you start getting into the wooey zone stuff, and you think about how like these wildfires kind of move and all that, it's just like imagine like an ember ending up on that, and then, you know, I mean, you know, how flammable is the solar panel?
Good question.
Yeah.
And that would be one thing. I mean, you know, if they are flammable, I wouldn't even think twice about it. I would not put it on the roof, you know.
Yeah.
Can I ask,
Mhm.
does anybody have experience with companies in the Bay Area that build like roll-off roof backyard observatories?
In the Bay Area.
That would do it for a Bay Area home. Like a lot of these companies, like you said, are in LA or whatever, or
Yeah. Well, a lot of them too, the ones that are down in LA or, you know, down in Southern California are, you know, they're doing like the ash domes and the, you know, the larger kind of like
right.
the plane waves and stuff like that, you know. The 20, you know, like the 24-foot ash dome.
Right. So no experience with somebody in the Bay Area. Is that it?
Yeah, I mean, I think, you know, like a lot of the framing and stuff like that is, you know, it's pretty standard. Like a lot of your kind of typical contractor can handle it, you know. It's not, I think the framing and stuff like that isn't, you know, it's not like, it's not that specialized, you know.
Okay. I know Alex, who's on the call, had a contractor build his uh, roll off. I know, Alex, you have any comment about that, or
Here's contract.
oh, maybe not.
Yeah.
I don't know if Alex is available.
Yeah, I mean, you know, contractors are, that's a whole nother topic.
All right.
Yeah. I looked into backyard observatories, BYO. I think
Hmm.
they're based out of one of the Midwestern states, and um, I heard that they stopped coming to the West Coast. I'm not sure why. I think maybe it's because they're a pretty small operation and there's a lot of demand. But I imagine the building codes out here and all the needing to protect against fires and earthquakes and things like that might have dissuaded them.
Yeah, well, it could also be that his, you know, his contractor license ran out.
They're
You know.
still building in other parts of the country, but just
Yeah, well, but that's something, you know, like the contractor license is given out by the state.
This is a test.
Just like a you know, like
oh yeah.
my architecture license is given out by the state. And I know like for, you know, it costs money, you know, for contractor licenses are much more expensive than the architect one is.
Yeah, this is Alex. I finally figured out how to unmute or actually get my microphone working.
Hmm.
Yeah, my normal contractor built my outdoor observatory, but it was part of a larger structure, which was an outdoor kitchen. So like one corner of it is a 7 by 7 foot observatory, and the roof is like 20 by 20 feet for the rest of the kitchen. So that quadrant of the observatory has a roll-off roof component. Um, and we had a structural engineer. The city required us to do structural engineer since we're building right next to a pool. So we ended
Mhm.
up having to put in a bunch of caissons for the foundation. So it's so one question I have is you know, I know you mentioned these deep foundations and that doesn't apply, but in my case it does. I'm imagining that would help in terms of the vibrations and things because I'm bolted directly to the slab.
Hmm. Yeah, I mean, you know, a lot of times like I worked on a project up in San Rafael, and it you know, the site up there was a lot of silty kind of soil, and we went right down to the bedrock. You know, like we had a pool, and the pool was sitting on, I think, 21 or 24 piers, basic, um they were, it was just piers basically going down to the bedrock. So the whole ground could, slide out from underneath the pool, and it would just be sitting there on top of these piers.
Yeah, I guess that was the theory of this, but so near a pool that apparently a pool could be considered a void. And so
Mhm.
the weight of the foundation, so the piers were designed to distribute the weight of the foundation below that of the level of the pool, so it won't impact it. So special case, it was a $30,000 foundation. So
Yeah, yeah.
be careful when you go to the structural engineer. He may suggest some things, but I did find that my contractor didn't have a lot of problem building it. My only regrets were oversights on my part in terms of, oh, I should have put a conduit here, or I might have chosen a slightly different rollers for the roof.
Hmm.
I let my contractor kind of pick something. I think it was undersized. So I suggest that if you're going with a general contractor, you're still going to do a lot of research on the observatory specific things because they're not going to know or prioritize those. But in terms of framing and building it, once you got the plans, I think any general contractor can deal with that.
Yeah, I mean, hopefully too, when you're doing the plans and kind of putting it out there for pricing and that sort of thing, that, like those rollers and the track and all that is really called out, and it's designed already, before it ever kind of touches the contractor, right?
Yeah, I've heard some contractors will balk at the idea of the roll-off part. Um, Even if it's just a simple shed, like that part of it kind of scares them.
Yeah. Yeah, I mean, contractors. I know I don't know. I guess in my like 20 plus years of experience, I've just, you know, I've just seen so much. So it's just, there are contractors out there, that are good, and there's contractors out there that are not so great. So I guess.
We do have a imaging SIG member who lives up near Mount Hamilton, who is building his backyard observatory. And he was working with his son on specialized rollers, a slightly different way that's usually done. And I don't know if he has completed that or not, but he might be a good resource.
Hmm.
All right. Well, I guess we're at an hour 45, which is probably long enough.
Yeah,
So, it's a long time and we
I can
really
stop sharing.
time.
Yeah.
But I want to thank you, Scott, for an excellent presentation. And
Um,
everybody else, could you do me a favor and unmute and give Scott a hand for his effort and his excellent presentation?
Thanks,
Yes,
Scott.
Thank you, Scott.
Thanks, Scott.
Thank you.
yeah,
Thank you.
I'm glad you enjoyed it. I wasn't sure.
Oh, no, it's great. Thank you.
Very informative.
All right,
Yeah,
everybody.
yes, we'll bug you more, Scott. 3.5.
Thank you.
Thanks, everyone, and we'll see you all in December. And I'm going to end the
You
call.
all. See you then.
Have a good
Bye.
night.
Bye-bye.